Hi chemistry students. I'm going to give you a brief tutorial about how to calculate average atomic mass. Now you should have already done the bean salad lab where you had some experience collecting data for kind of a pretend element with 3 different isotopes and then using those numbers to calculate. What I'm going to do now is run through an example with an actual isotope data with the element lithium. So I have some information here that I pulled about lithium. Lithium only has 2 isotopes. The one you did had 3. You're going to find, you might do some examples with other elements that might have 3 or 4 or more isotopes. But what we do for the periodic table is we take all that isotope information, average it together in a weighted average mass so that the number on the periodic table is just an accumulation of that for atomic mass. We have 1 square on the periodic table for lithium, not multiples for each isotope. So there's just 1 place for lithium's information, so this is how we average together the atomic mass of all the different types of lithium and put that number on the periodic table. No matter what element you're using, average atomic mass is calculated like it is here. You take the average atomic mass of the isotope, I'm going to put in isotope there actually, multiply it by its percent abundance, how common it is. Do the same thing with the other isotope mass, multiply it by its abundance, and you do that for however many isotopes there are, and you add all of those together. For this one, I'm only going to need to do that twice and add those numbers together because, again, there's only 2 isotopes. So here's what the numbers would look like for the average atomic mass of lithium. I'm going to deal with lithium-6 first of all. Its average atomic isotope mass is 6.015. I'm going to multiply that by its abundance, 7.5%. Now I'm going to go ahead and put that in the decimal form, which means dividing by 100 or moving the decimal to the left 2 places, so 0.075. I'm going to get a number for that and then also multiply it then by the other isotope, lithium-7. 7.016 is its mass, and I need to multiply that by its abundance, 92.5%. And again, I'm going to put that in decimal form, move the decimal to the left 2 places, 0.925. So I'm going to calculate this up. Even before I get a number, I can look at my data and predict that my mass is going to be way closer to the 7 number than it is the 6 because the isotope of lithium-7 is way more abundant than isotope of lithium-6. So I can kind of do that, think about that in my head to check my work to make sure I didn't punch something in my calculator wrong perhaps. Okay, so the number I get, and you should check this, let me know if I made an error, is 6.94. And the units are AMU, and that stands for atomic mass unit, very tiny units that we use to show mass of an atom. Now this number is reasonable to me because again it's closer to the 7 than it is the 6 because that isotope is much more abundant. And then if we were creating a periodic table and a place for lithium, this is the average mass that we would put for lithium. It includes all the isotopes of lithium. So again, same process for any isotope, except you might have more than 2 that you need to calculate and add together. Now on Canvas there's some practice problems for you to practice this, submit your answers, and I can check your work and make sure you're on the right track with this. Have fun!